Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. NASA's mission schedule holds a peculiar detail. Probes are planned for Venus in 2029 and 2031, while the ambitious Trident mission to Neptune, originally set for 2038, has been cancelled. The next opportunity to explore Neptune is not until 2049, assuming NASA maintains its plans. Despite the success of visiting Pluto in 2015, questions remain about why missions to Neptune are delayed. Are there concerns about potential discoveries that could reshape our understanding of the solar system and life on Earth? Mysteries surrounding Neptune persist, suggesting there's more to uncover. Since Neptune isn't visible on any ancient star map, the question becomes why it is shrouded in mystery. Even the most esteemed ancient Babylonian astronomers could only identify 6 of the planets that exist today. It wasn't until William Herschel at the tail end of the 18th century that the first ice giant, Uranus, could be observed by a regular telescope. However, compared to Uranus, Neptune is 1.5 times farther away. It travels 4.5 billion kilometers as it circles the Sun. The 165-year rotational period is due to the ice giant's orbit being 30 times broader than Earth's. Even Galileo Galilei, who had the incredible good fortune to see Neptune twice in 1612 against the backdrop of Jupiter's moons, mistakenly thought it was a dim star due to its great distance and extremely slow motion across the sky. The idea of another planet so far away from Earth was completely inconceivable to the renowned astronomer. The discovery of Neptune was enabled by imagination. In 1846, French astronomer Bain Leverrier observed anomalies in Uranus's orbit, hinting at a massive unseen object. Despite initial skepticism from colleagues, Leverrier's calculations pinpointed the new planet's location in the sky. On September 24, 1846, scientists at Berlin University confirmed its existence. Originally intended to be named after Leverrier, it was eventually named Neptune, fitting its deep blue appearance and mythological connections, though this was coincidental. Actually, no one on Earth had been able to view Neptune's surface for 15 years. Scientists weren't anticipating anything remarkable as the Voyager 2 spacecraft from NASA neared the ice giant in August 1989. They were expecting to find a frozen, lifeless ball at that enormous distance from the Sun where it becomes a faint star. On the contrary, they witnessed a planet that was astonishingly dynamic, with hurricanes releasing massive clouds and a large black spot whose cause remained a mystery. After the serene and an interesting Uranus, Neptune appeared as a fantastical world. Even more surprising was the simultaneous discovery of 5 additional ice giant satellites and the filming of the speculated ice rings by Voyager 2. No other Earthbound spacecraft has been to that area since this NASA probe soared farther into orbit. Nevertheless, Neptune sprung an unexpected surprise in the year 2022. With the help of the James Webb Space Telescope, astronomers were able to observe dust lanes alongside ice rings, which caused Neptune to resemble Saturn. There is overwhelming evidence that our understanding of this enigmatic, faraway planet on the solar system's periphery is severely deficient. Is it possible that scientists are reluctant to launch a new mission in order to keep the public informed that their understanding of Neptune's origins is extremely limited? Then why didn't Neptune originate right where we discovered it? Based on its precise appearance, planetary scientists could conclude that it is either too large or too small to fit into its present orbit. Recent gravitational wave computations have revealed that Neptune is 17.5 times heavier than Earth. The silicate nickel iron core contains around 20% of it. Underneath Neptune lies a gritty world. That world is slightly bigger than Earth and is covered with massive layers of different gases, primarily hydrogen and helium. Even though Jupiter is 18 times heavier than Neptune, it has a structure that is very similar to Earth's, and it weighs about 318 Earths. Space researchers initially saw nothing unusual. Jupiter formed in the central region of the protoplanetary disk, rich in light gases. Moving outward from the Sun, less material was available for planet formation. Hence, Saturn can weigh as much as 95 Earths, while Uranus is as light as 14.5 Earths. However, why is Neptune 1.5 times farther than Uranus, much heavier? If it originated in the outer solar system, it should be twice as bright as Uranus. The theory gaining traction suggests Neptune may have formed closer to Saturn's current orbit. Gravitational interactions then pushed it outward. Simulations suggest that young Jupiter's close approach to Saturn may have flung Uranus and Neptune into distant orbits. Neptune's escape from the solar system remains uncertain, hinting at its unusual history. You're probably not expecting to see a film about Neptune discussing a hypothetical planet. But there's an argument that the ice giant mercilessly shoved its solar system companion out of the way during this orbital dance, which is the only way it could have kept its place. Unfortunately, scientists are now contemplating other, more interesting theories regarding Neptune's birth because this one demands so many coincidences all at once. An analogy that has stood the test of time for the development of massive planets is the gradual wrapping of cotton candy around a stick. The process can go on for millions of years and involves gas building up around a solid center. Even if this were possible, it would take far longer for Jupiter to acquire its massive size than the amount of free gas in the early solar system allowed. In an effort to shed light on this disparity, researchers are turning to the Disinstability Model. Rapid cooling of the protoplanetary disk creates massive clots that, in a matter of 1,000 years, evolve into gas giant planets. Pulling a large lump of melted sugar straight from the tank is like skipping the step of waiting for cotton candy to be wrapped around a stick. This approach adequately explains not just Jupiter's size, but also Neptune's orbit. However, this result remains contradictory. This instability of the protoplanetary disk is not the only possible explanation for the ice giant's formation. If it were, the giant would be significantly larger than it is today, potentially even larger than Saturn. In a last-ditch effort to salvage this idea, Alan Boss, an American astronomer, put out an even more spectacular alternative. This theory states that Neptune had its mass violently removed. A large blue star, similar to Sirius, whizzed past our solar system, releasing half or more of the gas from Neptune and Uranus. Consider the possibility that it absconded with Planet X as well. The ice giants wouldn't be the only ones affected by an alien star of a greater magnitude, even though it is known that minor stars pass close to Earth's orbit around every 50,000 years. A massive star would undoubtedly sweep across the Kuiper Belt, a region that contains numerous dwarf planets and starts just beyond Neptune's orbit. Consider instead the scenario in which Neptune plays the role of the extraterrestrial star. The Harvard-Smithsonian Center for Astrophysics conducted a 2012 study that found that among our galaxy's billions of stars, there is a chance that one renegade planet may be captured and integrated into one of their systems. Some scientists use this as an explanation for massive exoplanets in extremely distant orbits, even though this kind of formation is theoretically impossible. Neptune may have evolved in a distant star system, sunk through space friends, and then been pulled into Earth's orbit by the sun's gravitational pull. That this ice giant may originate from a planet so foreign that our standard conceptions of planets are completely out of date is puzzling. If Neptune were an alien world that stumbled into our solar system, its incredibly strange shape would make perfect sense. Will the 1989 Voyager 2 snapshot of the Great Dark Spot remain a mystery to you? Because of its size, experts were keen to learn more about it. When the new Hubble Space Telescope was flown to Neptune by NASA 5 years later, however, the anomalous creation was not detected in the atmosphere. A lesser formation, which scientists dubbed the Dark Spot Junior, emerged close by in 2020 after Hubble had already detected a new massive spot near Neptune's North Pole in 2018. Neptune appears to be home to an extraterrestrial life form that we do not yet know about. They might extend over several square kilometers of Earth's ocean floor, much like enormous microbial colonies. They must have somewhere to roam on Neptune, the much larger planet, right? This notion is not given much weight by scientists. Dark patches on Neptune's surface are merely megastorms, similar to Jupiter's Great Red Spot, in their explanation. On the other hand, if ammonia compounds coat Jupiter, Neptune is essentially just 200 degrees Celsius of frozen methane crystals. They are believed to be the cause of Earth's general blue hue and are highly effective in absorbing red light. More and more crystals are being lifted from deep within the atmosphere, making the massive anticyclone appear darker. Since Jupiter is larger and hotter, it stands to reason that this storm on ice Neptune will move at a somewhat slower pace. Regardless, Neptune is devoid of reason. Indeed, winds can reach 2,100 kilometers per hour around the periphery of Neptunian storms. This is 1.5 times faster than sound and roughly 3 times faster than the currents in Jupiter's most intense storms. The question is, how is it even feasible to do such things on the ice giant? More heat is radiated into space by Neptune than it receives from the Sun, a difference of 2.5 times. Neptune is currently experiencing its 40-year warm season, but unlike other planets, it is actually cooling down. As if that weren't strange enough, scientists have just discovered this. It seems that some planetary heat engine with its own peculiar method of operation is hiding out amid the thick Neptunian cloud cover. How does it feel, though? A respectable probe to investigate Neptune's atmosphere will be on board any mission to the planet sent by NASA. Under the cover of clouds, it will embark on a protracted voyage through its remarkable thickness. The top layer, which reaches to a depth of 10 to 20% of Neptune's radius, is composed of hydrogen, helium, methane, and hydrogen sulfide, according to the scant data sent by Voyager 2. If you were to venture into such an environment, you would be stepping into the ever-condensing gases rather than solid rock that makes up Earth's core. The most of the time, it is completely black here, broken only by the occasional bolt of lightning from the endlessly roaring thunderstorms. The origin of Neptune's unusual heat is located far deeper in the mantle, and this is but one more effect of it. The tremendous pressure of the lowest atmospheric layers is 100,000 times stronger than Earth's, making it highly unlikely that any terrestrial probe will make it there. The mantle is heated to at least 5,000 degrees Celsius, depending to the heat given off by Neptune, as the temperature rises proportionally. All along the surface of the Sun, the temperature is constant. But the Sun is not an icy gas giant. It is a star. The Neptunian mantle isn't like Earth's imagined thick layer of molten lava. It's actually a deep ocean of water, ammonia, and methane impurities, 1.5 times thicker than Earth's mantle. Despite being solid due to extreme pressure, it remains thousands of degrees below freezing. Under these conditions, it forms a mysterious ionized supercritical fluid with unique properties, including high electrical conductivity. This contributes to Neptune's unusual magnetic field, stretching out into space for at least 35 times the planet's radius, but not aligned with its geographic poles. Potentially residing in Neptune's supercritical ocean is the heat engine and the source of this magnetic anomaly. The term diamond gravity generator best describes it. In 2017, scientists from Germany's Helmholtz Institute in Dresden were able to replicate the 1.580 m pressure that is typical of the Neptunian supercritical mantle by means of a robust laser system. Organic substances decompose in these environments, including methane. The force of gravity causes carbon, being the heaviest element, to descend to the ground, but under the immense pressure, it instantly condenses into diamonds. Neptune is home to objects as large as 1 meter in diameter, and the tremendous amount of heat generated by their friction with the surrounding supercritical fluid is substantial. Because of this, the ice giant is now the most costly planet in our solar system. A stone core encased in a layer of supergiant diamonds would be visible if the atmosphere and mantle were to be removed. To you, it seems like something out of a dream. But that is the exact shape that the most reliable scientific models of Neptune's interior take. Objects surrounding Neptune appear like they came straight out of a science fiction novel, and scientists are still perplexed by what lies within. Similar to the asteroid belt between Mars and Jupiter, but 10 times broader and somewhat less researched, is the Kuiper Belt, which is next to the ice giant's orbit. Although dwarf planets abound in our twilight zone, Pluto stands out as the largest and most famous of them. A little over 1,100 kilometers in diameter Chair object was found in the Kuiper Belt in 2002. While it may not be perfectly round, it certainly resembles a massive asteroid. The unexpected acquisition of the small satellite Waiwat by Hubble near Chair caught astronomers off guard. The rarity of stellar binary systems is remarkable, yet it is far from the most peculiar occurrence. From 2018 through 2020, astronomers observed chaos circling the stars and detected a ring of debris in Waiwat's orbit. Despite how gorgeous it all is, it shouldn't exist based on all estimates. When faced with another smaller celestial body 4 times its diameter away, Chair simply could not have torn it apart. However, the second satellite of Chair would have merged with a ring of tiny debris from the Kuiper Belt long ago, even if it had miraculously collected it. Scientists still don't know what's causing this occurrence, but they suspect the mysterious ring has something to do with Waiwat. On the other hand, I can think of a better one. What if, by chance, scientists discovered an artificial structure, like a cluster of solar panels surrounding a spacecraft that has been abandoned for a long time? Regardless, a search for extraterrestrial life on the solar system's periphery would be better served by focusing on the region around Neptune. While flying by the ice giant in 1989, Voyager 2 also focused on its largest satellite, Trident, which is just smaller than the Moon, according to the spacecraft. Even though the device only captured a fraction of its surface, this was enough to confound researchers once more. Trident may be the solar system's coldest celestial body at a temperature of about 40 degrees above zero, but the satellite's varied terrain betrays its constant geological activity. It seems to come from cryovolcanic eruptions, which release dust, water, ammonia, and methane. The cryovolcanoes of Triton, which look like geysers on Earth, left multi-kilometer trails that scientists were able to detect. However, they're yet to reach space itself here because of the incredibly low gravity. Astrogeologists are discussing the possibility of an under-ice ocean on Triton as a result of all this, with liquid eventually making its way to the surface. Possible thawing caused by radioactive decay in Triton's core prevented it from freezing. Thus, Triton, the moon of Jupiter Europa, and the moon of Saturn Enceladus could be among the most promising candidates for the search for extraterrestrial aquatic life. Because Triton has an unusual retrograde orbit, it differs from other satellites in this respect. Its rotational axis is perpendicular to Neptune's. This indicates that it was unintentionally caught by the ice giant's gravity rather than having formed with it. Extraterrestrial Triton hails from the Kuiper Belt, if not from outside our solar system altogether. Is it possible that Triton is a dwarf planet that was once part of another star, but when it approached Neptune, was merely swept into its orbit as a result of planetary gravity? Simultaneously, research into the ice giant's rings and other smaller satellites uncovered evidence that the extraterrestrial likely shattered Neptune's older natural satellite during its journey. As an additional oddity, Triton has an incredibly robust ionosphere compared to other celestial bodies of a similar size. The stunning image we have might not just depict a dwarf planet in Neptune's orbit, but possibly an underwater civilization with facilities creating an anomalous ionosphere. Irina Romanovskaya from Houston Community College proposed interstellar travel methods that make such theories plausible. If NASA detected an anomalous signal from Neptune's moon Triton supporting these ideas, perhaps the sudden termination of Neptune missions would seem more understandable. With 1/3 of identified exoplanets showing similar traits, Neptune's mysteries deserve further exploration. James Webb might even detect atmospheric biomarkers hinting at extraterrestrial life vastly different from our own, possibly dwelling in Neptune's enigmatic environment. Any thoughts on why NASA postpones missions to this ice giant? A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.